This video is for lesson 3 of the Year 7 Light topic entitled Refraction. By the end of the lesson you should be able to recall what happens when light travels from one transparent material into another, be able to draw diagrams that demonstrate the effect of refraction, and be able to explain why refraction occurs. Okay, you may have seen an effect like this, maybe with a drink straw in your glass, in this case a ruler in a washing up bowl filled with water. The ruler appears to be broken or bent, but when you pull it out it's perfectly straight, and also this part of the ruler here also appears to be near the surface, when in fact it's actually lower down in the water than it actually is. Okay, so today we're going to explain why this happens. We're going to look at a particular experiment to help us understand why that happens, and this needs to be in your notes. Okay, so an experiment that you can carry out using equipment similar to the reflection experiment, but using a perspex, a plastic, or a glass block instead. Okay, if you shine a ray of light along this line here, that's our incident ray, our incoming ray, and it hits the block there. Remember, this is glass or plastic. This line here represents the normal. Again, something we met in the reflection lesson. The normal is an imaginary line which is at right angles to the surface at the point where the incident ray strikes the block. That ray of light will then be caused to change direction. So it ordinarily go along in that direction like that, but it's caused to bend or refract in this direction here, heading towards the normal. Okay, so it would have gone that way, it's been bent heading towards the normal. When it comes out of the block, we're drawing a second normal here, then the ray of light is bent or refracted away from the normal. Okay, so what's actually happening when that ray of light hits the block? Well, when light travels in air or through empty space, it's travelling at around about 300 million meters per second. That's about 1,000,000 times faster than sound. When it hits that block, it goes into what we call an optically more dense medium. It finds it harder to travel through glass than it does through air, and because of that it bends towards the normal. So whenever light travels from a less dense medium or material, that term medium means material, when it travels from a less dense medium into a more dense medium, it's caused to slow down and bend towards the normal. Now when it comes out at this point here, it's now travelling from glass into air. Air is a less dense medium, and so the beam of light speeds up, and this time it bends away from the normal. Okay, so from less dense to more dense, the ray of light bends towards the normal. When it travels from more dense to less dense, it bends away, and all due to the fact that it changes speed. Now if you shine a ray of light down the normal line here, like so, you'll find that there is no bending or path deviation at all. Now the light still slows down. Okay, so when it enters here, the block, it still slows down, but it doesn't bend or change direction. Now the reason for that I'm going to show you in the next little video clip here, but you do need that diagrams carefully drawn in your exercise book. You might be asked to reproduce them in a test. So pause the video and do that now, please. We can use a model to help us understand why light bends when it enters a block at an angle. So the road here is going to represent our beam of light, in which case our racing car travelling through air. The mud patch here is representing the glass or plastic block, more dense, harder for the light or car to travel through, and therefore causes it to slow down. So let's have a look then. There we go, took a little bit getting there, but we got there in the end. Okay, so when the car goes, you'll notice that this wheel here, shown here, hits the mud first, so this wheel slows down, but this wheel here carries on at the same speed, so the whole thing turns in a direction heading towards the normal. It's a bit like if you're in a rowing boat and one person pulls harder than another. It's caused a turn in the direction of the person who's pulling harder. In this case, it's turning in the direction whereby the wheel is slowed down first. Now, once all of the car or all of the beam of light is in the new medium, it will continue to travel at a steady speed and therefore will travel in a straight line. Now, if we're talking about light, we've already said that light travels at 300 million meters per second in air. In glass, it slows down by about 2/3, so only about 200 million meters per second. And when it comes out, this time this wheel gets out first, so it starts to speed up first. This remains slow and it causes it to rotate in that fashion there. Now, you will not be asked to explain this in your test in Key Stage 3, but you could be asked to do that in Key Stage 4. Okay, so just a little explanation as to why it bends. Incidentally, if it were heading down the normal line, then all two front wheels would slow down at the same time and the thing would carry on at a steady speed. Okay, finally for your notes then, could you put that title Refraction? Could you make a copy of the couple of paragraphs here, and can you insert the words from down here into those spaces? So could you do that now? Pause the video and then we'll go through them together. Okay, let's go through these then. Refraction is when waves speed up or slow down due to travelling in a different medium. A medium is something that waves will travel through. When a ruler is placed in water, it looks like this. In this case, the light rays are slowed down by the water and are bent, causing the pen to look odd. The two mediums in this example are air and water, or water and air. You could have those either way around. Okay, what I'd like you to do now is to complete the progress quiz that has been set for you for the first 3 lessons on Caboodle. If there is anything that I've missed in the lesson that's on the Caboodle test, or the exercise I should say, then do use the exercise book pages which I've highlighted at the start of this video with PowerPoint. Okay, so you should now be able to recall that when light travels from one transparent material or medium to another, its direction can change. You should be able to draw a diagram that shows refraction taking place, labelling the incident and refracted rays, the angles of incidence and refraction, and any normal lines. You should be able to explain that refraction is caused by light changing its speed when it enters or leaves one transparent material to another.